Welcome to today's lecture. We are going to start basically with the center of mass, and then we will discuss equilibrium state, right? In today's entire lecture, one by one we are going to cover all the steps. There are a lot of things to be discussed inside this particular chapter, so step by step we will be proceeding into it. Okay, so currently I am going to transfer my camera back to the board setup. Yes, so be there. So here we go. Here it is. Yeah. I'm just rubbing this off. And topic as discussed, we'll be continuing with force. Camera setup is okay? Yes, here we go. It's okay. Force. Right? So we have got 10th ICSE chapter 1. That's what the part is, right? However, it can be used by all the people. There's no such problem. It's just about the syllabus and other things up. So I've written it here, over here. Today I'm going to discuss something called as equilibrium. And also we have discussed center of mass concept. Yes or no? Center of mass concept is already discussed. So we will see what exactly is equilibrium. Okay, mind it, equilibrium ka matlab hota hai, it is a stable state. When I say equilibrium, it means I am talking about the stable state. Stable state. By the way, the term equilibrium itself says something. What is it? Equilibrium means when the sum total of force and understand this, acting quantities become zero. This is very interesting, huh? Becomes zero. Now understand this. When you say sum total of two things, see, understand, I have not written sum total of force. I have written sum total of force and acting quantities. What does this mean? See, understand, acting quantity, by this word acting quantity, I mean to say moment of force. Okay? Why? Because if force acts generally, it creates the translational motion. If the moment of force acts, it creates the rotational motion. Right? Yes. So in both the cases, we consider the force and acting quantities. So in some books write force only. That's okay, because force, it can be angular or it can be linear. Linear force is just force, and angular force is nothing but moment of force. So it's okay if some books, some textbooks, some people, they say it is just force. No problem. As such, sum total of force and acting quantities becomes zero. Then we say, just one second. Then we say that the system is in equilibrium. Okay, now understand this. Let's write the definition of equilibrium. Let's write the definition of equilibrium. Okay, just start. Okay, you can note it down later. Just do not start writing right now. Talking about center of mass, we had already discussed. What is it? What is it? What is center of mass? See, what is center of mass? A point mass on the body. On the body where the entire weight is supposed to be concentrated. Is supposed to be concentrated. अच्छा एक बात समझ लो, when the entire weight is concentrated at one point, it means what? It means what? Such that such that the body stays in equilibrium, stays in equilibrium with pivot at that point. At that point. Very very important parts, understand this. सबसे पहली बात, a point mass. दूसरा, the entire weight is supposed to be concentrated. Clear? और तीसरा, तीसरा, the body stays in equilibrium. I'm trying to correct this equilibrium का definition with center of mass. The body stays in equilibrium. लेकिन कब? When does the body stay in equilibrium? We had seen the example, right? If I hold the body at that point, body stays at equilibrium, right? Yes, no? What is center of mass? That point where if I hold the object, it stays in equilibrium. So that's what I've tried to write. Okay, so such that the body stays in equilibrium with pivot at that point. Mind this definition is not something which I have tried to recall from certain book. It is the understanding of subject that helps you to create definitions. So make sure that you are understanding both the concepts very clearly. If the things are very clear, there is no problem. Got my point? Yes, no? Okay? Okay. So just write this up quickly. Write this up. What we will try to do basically is we'll again write the definition of equilibrium, but this time with the concept of moment of force. ठीक है ना? पक्का? So equilibrium with respect to moment of force क्या होगा? Equilibrium is that state of the body when the anti-clockwise moment is equal to clockwise moment. समझा क्या? Equilibrium is that state of a body when anti-clockwise moment is equal to clockwise moment. खत्म. या total sum of the anti-clockwise moment is equal to total sum of the clockwise moment. Agreed or not? Right? Yes? पक्का? So अगर मैं क्लॉकवाइज को पॉजिटिव बोल दूं, सॉरी एंटी क्लॉकवाइज को पॉजिटिव बोल दूं और क्लॉकवाइज को नेगेटिव बोल दूं और दोनों इक्वल है, तो दोनों को ऐड करने के बाद क्या होगा? दे विल कैंसल ईच अदर. सो इक्विलिब्रियम का एक तीसरा डेफिनेशन भी बन गया. क्या सर? व्हेन द सम टोटल ऑफ ऑल द मोमेंट्स ऑफ द फोर्स ऑन द गिवन बॉडी एक्टिंग अपॉन अ बॉडी बिकम जीरो, वी से दैट द बॉडी इज इन इक्विलिब्रियम स्टेट. है ना? वो इसके जैसा डेफिनेशन है पूरा. एक्चुअली यही डेफिनेशन है, पर इसको मैंने जनरल बना के दिया और हमने दो डेफिनेशन मोमेंट ऑफ फोर्स को जोड़ करके देखा. है ना? बोथ द डेफिनेशंस आर करेक्ट. यू डोंट नीड टू मग अप एनी डेफिनेशन. इट इज जस्ट अबाउट योर अंडरस्टैंडिंग. Clear? Yes, no? So write both the definitions. Write both the definitions. Write it. Okay. See this definition I've tried to modify. Sum total of force and acting quantities. इसको मैंने replace कर दिया. Sum total of moment of force becomes zero. It is in equilibrium. Just do it. Write this up. For any physics question that you come across, if it is numerical, make sure that you know how to draw the diagram. Fill in the data into it. Once the diagram is made, data has been filled, your automatic IQ gets initiated, and that is what is needed, to solve any damn problem. You can just mention the formula that you want to use and all those things over there itself. So it will make you very comfortable in framing out the steps that you are required to take. Okay, so this sum also which we are going to solve now, what I'll do is I'll use some diagrams to solve. Okay, I'll just read the sum first, and the sum is: a physical balance has its arms of length 60 centimeter and 40 centimeter. So there is a balance. It has got two arms. One is 60 centimeter, other is 40 centimeter. Okay, so total is 100 centimeter. Mind this. Total is 100 centimeter. So 1 meter long. Okay. What weight kept on the pan of longer arm? Longer arm कौन सा वाला है? 60 centimeter वाला. Right? So what weight? Weight का वहाँ पर weight you can make and then put the question mark. I'll show that on the board. Don't worry. I'm just reading the question first. So what weight kept on the pan of longer arm will balance an object of weight 100 GF. When you say 100 GF, understand this? It means it is not force, huh? It is not force. It is mass which is given over there. You'll have to multiply that and then get the value of force. Okay, again. Kept on the other pan, no problem. So we'll make the stuff over there. Yes. So I'm switching the board now. Here we go. So here is the diagram. Okay, this is 1 meter long stuff. The pan, 40 centimeter, 60 centimeter over here. The question is, a weight has to be put on both the sides. Okay, so the physical balance has its arms of length, whatever. So what weight kept on the pan of longer arm? Okay, so which is the longer arm? This is longer arm. So suppose if I have to put the weight here, right? Or you can say in this part, say if this is the center of mass kind of thing, so you can consider this thing. Okay, so this is there. Well, this weight is question mark. We don't know this. Okay, right? And this weight has been mentioned. How much? This weight is mentioned. It is 60? 100 gram. Okay, sorry. 100 GF. Pakka na? Okay, so if that is the case, look at the diagram. This will clear a lot of things. Can I say this is V1? And this is going to be, say, M1, load 1 or W1, whatever you call it as. Yes, no? Yes or no? Right? This is very special and easy as well. Huh? अभी जरा समझना है. Same is the case over here as well. So this is say L2 or R2 or D2, whatever you call it as. So I'm writing here say D1. Okay. And I'm saying here this is D2. And M1 we don't know. So M1 is equal to question mark. And I will say here mass is what weight which है ना? Sorry, W1. W1 is equals to question mark. And say W2 is given over here. Can you see this? Yes or no?
Yes,
right? Sir. So now tell me the idea. By the equilibrium formula, हमको पता है already क्या होगा, right? So we will go to the equilibrium formula. So by law of equilibrium, what will be the scene? What will be the scene? W1 into D1 shall be equal to W2 into D2. Yes or no? Okay, so this is what we have. by the law of equilibrium. Okay. Now one question: why is still W1 given? Because W1 is force. Okay, acting downwards. W2 is also the force. So this is what we can consider properly, right? So we will substitute the formula and get the answer. Sir, how about the weight of that pan? Yes, weight of pan also acts there. It is correct, but it is negligible because effectively it is being designed by that particular stuff that weight should not affect the upper area where the balancing is to be done with. As such, yes, if you keep these two things empty, automatically this pan is going to slide on this particular side, right? If I do not put any of the weights over here, the pan is going to you can say slide down to the right side. This is very important. So it will undergo the anti-clockwise moment there. Here also it will be the same case. If you put in W1, you'll get the answer like this. Okay. So here the weight of pan has been actually neglected. Okay. Yes. A uniform meter rule of weight 10 GF, yani gram force, is pivoted at its zero mark. Where does the scale have its zero mark? Where does the scale have its zero mark?
It's one end.
On
Exactly.
one end.
At its one end. Very good, very good. It's pivoted at Sarvesh. Okay? Yes, Sarvesh. Fine, good, good, very good. So now, what is being asked is, what moment of force depresses the rule? What moment of force depresses the rule? It does mean what? It means how much force is actually depressing the rule. The rule is going to be depressed, right? Okay.
Yes.
Let me open my Windows to explain you people. So this is the rule I have. So this is the meter rule I have. And I hold it over here the way I have done. Yes. So automatically this is going to go down by itself. Yes, no? So what is it that is actually pulling it down? What is it? Its own mass, because of which there is a gravitational force which is acting downward. And this gravitational force is lying at certain distance from the point of pivot. Correct. So that is creating the moment of force. This moment of force is actually pulling it down. Yes, no?
Yes.
Correct. So let us try to understand this in sort of broader detail. Right? The question is, what moment of force actually pulls it down? That is a question. Then what is the second question? How can it be made horizontal? By applying a least force. They are saying, how can you make it horizontal? There can be many ways, but they are saying you have to apply the least force. Okay, so this is very, very important. How will you do that? Let's see. Shall we try?
Yes.
No? Okay, so let's see. I'll do that. I'll just draw the diagram in front of you guys. This is the rod pivoted at this end. It weighs somewhere around 10 grams. So its weight must be acting down. And because it is uniform, so all the points on the rod must be having some weight at least. Getting my point? All the points on the rod must be having some weight at least. Right? So if some weight is available, so every point is acted upon by the gravitational force downwards. Yes or no? So automatically your rod is going to move like this. Correct? Yes. So if the rod is going to move like this, and suppose I pivot it here, the rod is going to move like this particular setup. So there's no such problem. But the concern is, can you calculate every weight over here? Every point's weight calculating is possible or not? Is it possible to calculate the weight of each and every point? The weight, the force acting on each and every point? Is it possible? Practically. Sarvesh. Is it possible to calculate weight at each and every point on this rod?
No, sir.
Sanya? Right? It's not possible, sir. Right? It's not possible to calculate weight on each and every point. So in such cases, what to do? In such cases, what to do? but it is not possible to calculate weight at each and every point. So what to do? The good thing about this particular rod is this rod is uniform rod. This rod is uniform rod. Uniform means every particle on the rod is having same mass. Every particle on the rod is having the same mass. It is made up of infinite. Thickness is uniform. There is no thick thin kind of thing. It is just the uniform rod. Okay. So beauty is if such kind of figure is available, this is geometrically definable. Something which can be geometrically definite, right, Mank? Yes. So because you can
Yes,
define
sir.
it geometrically, so I will say, sir, this is 1 meter. This entire thing is 1 meter. So where would it be the center of mass? The center of mass would be somewhere over here. तो यहाँ पे एक बहुत important note है which you need to understand. Sir, what? Center of mass is actually the geometrical center of यूनिफॉर्म बॉडी. यूनिफॉर्म बॉडी, जो बॉडी यूनिफॉर्म है ना उसका ही ज्योमेट्रिकल सेंटर जो होता है वो सेंटर ऑफ मास होता है. जो बॉडी यूनिफॉर्म नहीं है उसका ज्योमेट्रिकल सेंटर ऑफ मास नहीं होगा. ध्यान देना मैं क्या कह रहा हूँ. यूनिफॉर्म का मतलब पूरा बॉडी एक जैसा, पूरा बॉडी एक जैसा. अगर मान लो ऐसे जैसे हमारा बैट होता है. आई शो एन एग्जांपल ऑफ बैट. कैन यू लुक एट दिस बैट? आई हैव गॉट अ बैट. Yes, this bat is not uniform. Sir, क्या बात कर रहे हैं? हाँ, look here. See, here it is thick. Can you see? Here it is quite thin. Right? So there is a difference of thickness and thinness. So this is not uniform. Okay, what does the uniform mean? Everything has to be the way it is. Right? So that is called as uniform. Mobile phone, look at it, see, look at this. See? Can you see it? Perfect. Exactly the same structure. Right? This is uniform. This is uniform. This is uniform. Bat was not uniform. Bat was not uniform. Now, look here. So because of that, the center of mass will be at the geometrical center. Clear? So there is the geometrical center. If this is 1 meter, so automatically so this will be the geometrical center. What? So the force is actually going to act on this point. Yes, no?
Yes.
Right? Center of mass is also called as center of gravity. So don't get confused by these two words, okay? It is also called as center of gravity. Just don't get confused. It is just the subject of gravity we are talking about. This is for all the forces. That's all. If you introduce the gravitational force, it becomes center of gravity, as it is all the forces. So here we go. We have got this distance as 50 centimeter. Okay, so this is 50 centimeter, and I think now it is solved. This is 10
Yes, sir.
gram force. That's all. It's done. Now you can find out moment of force very easily. Yes or no?
500.
It is 500 what?
GFCM.
GFCM. Very, very good. It is 500 GFCM. Why? The first part was how much moment of force is there. So moment of force, you can write it like this. Say this is F. This is F. Okay, and this distance is say D. Correct? So moment of force is equals to F into D or D into F, whatever you call it as. And then we have got 50 into 10. So finally it gets to become 500 GFCM. Right? Yes, and this will go down. Now my question. Suppose if you want to balance this up, then how much force is needed and in which direction? Actually आप लिख भी सकते हो. Okay, this is there. ये नीचे की तरफ जा रहा है. Now if suppose you want to balance, then what is it that you need to do? कैसे करोगे balancing?
Same moment in opposite direction.
हाँ?
Same moment in opposite direction.
तो सेम मोमेंट इन अपोजिट डायरेक्शन आप लगाओगे, बराबर है. बट सेम मोमेंट कैसे लगाओगे? या तो आप इसके ऊपर दूसरा फोर्स लगा दो. yes or no? Yes. So you apply 500 GFCM at the center of at the center of gravity in the opposite direction. So it will be balanced. Yes, no?
Yes.
Right? But just read the question well. What is the question? What is the question, you tell me? How can it be made
The
horizontal by applying the
least force.
this is the key. You are not allowed to apply the force of 500. Understand this. If you apply the force here, it will be greater than 500. समझ में आ रही क्या बात? If you apply the moment of force from this particular direction, okay, so whatever force you apply, automatically the moment can be 500, but the force will be greater than 10 in these areas. The force will be greater than 10. Yes, no?
Yes.
Come here, automatically the distance has been reduced. So if you reduce the distance, force will be greater. And if you go here, the force will decrease. So what exactly is the requirement? The least force. Where will be the least force? At the outermost end. Yes, no?
Yes.
Yes.
I'll repeat. See, this is the object. This is the moment that we have experienced because of the object by applying no force. Right? So because of this, the rod is going to, a meter rule is going to fall down. Yeah, it will move into this particular direction. Now we want to make it horizontal. So making horizontal is very easy. You apply the force in the opposite direction, right? To counterbalance this moment of force. So how will this moment of force be counterbalanced? By equilibrium concept. So what does the term equilibrium mean? The moment of force on this direction is equal to moment of force on that direction. Now when you start applying the moment of force in this direction, there are options. Where will you apply the force? You can apply the force from this point to this point. Right? Yes. So if you apply the force nearer to the pivot, automatically the amount of force will increase to balance this particular thing. Right? So if suppose this is the point I am considering as partition, at all the points to the left hand side of this, the force required to balance it will be larger. At all the points to the right hand side of this, force required will be smaller. If and when you start going away from the point towards right hand side, the force applied will decrease to counterbalance this moment of force. Yes, ki no?
Yes,
Right?
sir.
Yes. So this is the point which is the farthest point from this particular setup. So if you apply the force here, the force required would be minimum. Sir, why not to apply force here? Because this is not the part of body. Yes, no. This is not the part of rod. You can apply the force here, but again, this is not the part of rod. You can apply the force here, but this is not the part of rod. So where is the part of rod which is farthest? This is the part of rod which is farthest. What is the distance? What is this distance?
100.
Very good. Yes. So this is the distance where you are going to apply the force, which is at actually 100 centimeter.
Centimeter.
Correct? So the force applied has to be in the opposite direction. The force applied has to be in opposite direction. Okay? Right? So this will be the force application. And that is what the question is. Clear? Yes, no?
Yes, sir.
That is the reason why I say this is F1 and this is D1. Now this will be F2, which is equal to question mark, and this will be D2. Clear? So shall I rub this
Yes.
off? Shall I rub this
Yes,
off?
sir.
Pakka na? You have noted?
Yes.
Yeah, have you noted
Yes.
it? Okay, okay. I'll just rub this off and write something here. Look, for the force to be least, यहाँ मैं लिख रहा हूँ by the law of equilibrium. By the law of equilibrium, distance from pivot has to be highest या largest, आप जो भी लिख दो है ना, implies B2 is equal to 100 centimeter. Clear है ना? Since F1 D1 is equals to F2 D2, therefore you require D2, right? No, sorry, you require F2. I'm so sorry. You require F2. So F2 is equals to F1 D1 upon D2. Just substitute and get the answer quickly. You have got F1, F1 is here, D1 is here, D2 is here. Just substitute and get the answer. And tell me how much is it going to be. You already know F1 D1. See, you already know F1 D1. Where is it? So it has to be 5
gram force.
At what distance? Even distance you have to mention now.
At 100 centimeter.
Where is the question? Where is the question? Just misplace the question. Right? At 100 centimeter. You will apply the force of 5 GF at 100 centimeter in the upward direction. Mind it, huh? This is the reason why I put the arrow like this. I've put in the arrow like this. So right there, you will apply the force of 5 GF at the distance of 100 centimeter in the upward direction. Just do it. Because dynamic can be further classified into two types. We'll discuss.
Yeah.
See, when I say types of equilibrium, this is very interesting concept. So, we all know what the equilibrium is. So, when the external force, the net external force and its agents become zero, then we say that the object is in equilibrium, right? Yes. So when I say it becomes zero, understand this. What does the force do? Why is force important? Why is force important? I had already shared some videos with you people. Have you seen that? Why is force important? Force is important because it creates, it leads to, yeah, it is the cause of change in states of object. States of object. Understand this, huh? When I say it is the cause of change in states of objects, what does this mean? How many states of objects are there? Can anybody tell me? How many states of objects are there? How many states of objects are there? I'll repeat. Okay, there are 4 states of motion, which are rest, and then 3 motions: uniform motion, uniformly accelerated motion, non-uniformly accelerated motion. Okay, so force is responsible for changing the states of object. But the object is made to sit from one state to another state. Okay, that is why it is written as cause of change, right? So if the force acting leads to cause of change and the total force acting becomes zero, it means there is no change in state of object. Yes, no? So equilibrium of the body actually connects you with no change in the state of object. So if the object is at rest, it will stay in rest. If it is in motion, it will stay in motion. Okay, so that is the reason why we have got 2 types of equilibrium. One is static. Anything at rest is called as static. Okay, the other is we have dynamic. Dynamic. Anything in motion is called as dynamic. Understand this. Static and dynamic. Dynamic motion can be further because the motion, as you said, people, that motion are basically of two types. So you can just say, sir, this is actually linear or translational. Or rotational. This is something which is acceptable. That is the reason why I said even this is possible. Okay, so equilibrium is basically of static type in which there is no motion, the object is at rest. Forces are acting, but they get nullified, because of which the state of rest does not change. Then I will say it is into the static equilibrium. If the object is in motion, say uniform motion, okay, and the forces are acting, understand this, forces are acting and there is no change in the motion, then I will say it is dynamic equilibrium, right? Dynamic equilibrium deals with understand this. Dynamic equilibrium deals with something called as uniform motion in particular. Uniform motion in particular. Understand this very, very well. Non-uniform motion can never be in equilibrium. This is very important that you need to understand. A non-uniform motion can never ever be in equilibrium. Non-uniform means the motion having acceleration. If there is acceleration, what is force? It is mass into acceleration. So if there is acceleration, it means there is force. And if there is a constant force acting and effect is being produced, it means that forces are not nullified, so they are never in equilibrium. This is very important point that you need to understand, that when I say dynamic equilibrium, it is subject to the uniform motion. Non-uniform motions have accelerations in existence, and because there is acceleration, there is always a constant force acting, and because there is always a constant force acting, there is always an effect which is there. Because there is an effect, there is always a change of state, and because there is change of state, it is not in equilibrium. So understand, static rest, there is no problem. Dynamic equilibrium always deals with uniform motion. Clear? Yes, no?
Yes.
Okay, just note this down. Note this down. Now we will do something very different and pretty popular these days. It is basically the concept of couple. Couple. The word itself means something, right? Couple is talking about pairs. Now understand this. Understand, this is very special. Couple discussed in force gives you something very interesting scenario. Just I'm trying to explain this up. Suppose if I have got a rod like this, okay, right? And what I do is I try to apply a force from this direction, and here also I'm going to apply the force in the same direction. So they're equal forces, right? So these two forces are actually acting as parallel forces. Yes or no? They are parallel forces. So if I apply the force here, many people would have done, even we can do. So if I and you apply the force over here, what will happen? These two forces will get added in magnitude, and the object is going to move from this point to this point. Yes, no?
Yes.
Correct? Huh? Okay, sir. If I apply the force, now understand this. If I apply the force like this, one force here, and at the same point if I apply another force, again they are equal in magnitude, right? So such forces, such two forces are called as opposite forces. Opposite forces, right? What will happen? They both of them will cancel each other. Yes or no? Yes, no? Why? Because they are negative to each other. So total force will become zero. If this is plus 2, this will become minus 2 newtons, and both of them will cancel each other. If this is plus 2 and this is plus 2, then both of them will add up and get transformed to plus 4 newton. So these are two special cases that we have. Now understand one thing. I'm showing a different example now. If suppose I have got a body like this, or a rod like this, and I start applying the force from this point, yeah, at this point, and also at this point. This is very interesting. What will happen? See, look at the line of effect for this force. and look at the line of effect for this force. Can you see this? Yes, no?
Yes.
Both the forces are parallel but opposite in direction. This is very interesting. Look at them. They are parallel but because they are in same directions, right? In this case, what is happening? They are parallel but in opposite directions. Such kind of forces are called as anti-parallel. Anti-parallel. Why anti-parallel? Because their line of action or line of influence, they are parallel and the forces directions are opposite. One is going upward, other is going downward. Okay, but the line of action or line of influence both are parallel to each other. So we say this is anti-parallel. Understand this? We have got parallel, which add up. We have got opposite, which basically cancel each other. We have got anti-parallel forces acting on the same body. Now I will show you an example. Look here. Okay, what I'm going to do is see. Can you see this? What is happening? Oh, right? There is very special thing which is happening here. See what is happening. Parallel forces add, right? And what do? They create translational motion. They create translational motion, a translational effect, right? Opposite forces and negative forces cancel each other, right? And there is no effect. There is no effect. But when we talk about these forces which are anti-parallel, they are very different. They do not add up. They do not add up. They create moment in same direction. They create moment in same direction, and the result is rotational effect. Rotational effect. Can you see this? This is very, very special. Two anti-parallel forces acting on a body separated by certain distance. Mind this, even these two are anti-parallel, if you can see them. But because they are acting on the same points, they become opposite. They become opposite. In this case, what is happening? They are acting at two different points separated by certain distance. Interesting or not? Interesting or not? Yes, no. So
Yes,
they
sir.
create. See, this will create clockwise moment, and even this will create clockwise moment. So both the moments will be added. Both the moments will be added, and the body will rotate. When the body is rotating in this scenario, automatic center, by default center of rotation is the geometric center. Yes or no?
Yes.
This geometric center is the by default center of rotation, right? So this entire body is going to rotate like this. So if suppose the length is d, this length will become d by 2 and this length will become d by 2. Yes, no?
Yes.
Right? So the moment of force created by this force, say it is F, is the force. So moment is F into d by 2. Here also F into d by 2, both in the anti-clockwise direction. So minus F d by 2, minus F d by 2. Add it up, you'll get minus Fd. Yes or no? Yes, no? I'll
Yes.
repeat. I'll repeat. Suppose if, where is my blue pen? Suppose if this force is D, F, sorry, and this force is also F, right? This entire distance is say D. So automatically this distance is going to be D by 2 and this distance will also be D by 2. Yes, no? So
Yes.
moment of force created by F, understand this. Here, the moment of force created by F will be F into D by 2 and the moment of force created by this F will be again F into D by 2. So what is the total moment of force? Add these two. Yes, no? So look here, I'll write a total moment of force is say M, right? So M will be addition of these two resulting into F into D. Yes or no?
Yes.
Correct or not? Right? Yes, such arrangement of forces. See, these two are forces. I'm not talking about other. I'm simply now talking about forces. Till now, we have discussed all the things. Now, let us focus on force. So, such two forces which are anti-parallel acting on the same body. I'll just write these points. These are very, very important points. What? सबसे पहला it must be anti-parallel. Then second, it acting on the same body. Same body. Yes, no? Right? Third, separated by certain distance. This is also very important concept. Certain distance. This distance is important. यहाँ पे distance क्या है? D. Yes, no? They are separated by the distance D. Yes, and they have got their center by default. If you change it, it is different story. But generally, center by default will become D by 2. Yes, such kind of things, such forces, such pair of forces are called as couple. Getting it or not?
Yes, sir.
Paka, is it not interesting, Sarvesh?
Ah,
Anuj and Mayank is okay. Yes, very, very good. Very good. So just note this down. I hope it is very clear now. Please note. Taps and all, they are open like this only. All the tap that you have, tap, opening of tap, opening of valve, those things happen because of this only. Continue. Just write this up. Those other people who are on recording stuff can pause their video and then start writing. Just pause the video and write. Others will simply write. Mind this, when I say center over here, I'm talking about pivot, okay? Center by
yes,
default,
sir.
pivot. Pivot is at D by 2 by default. If you change by certain mechanism, the things are different.
Yes.
Please understand this example. Again, I am repeating. If suppose I apply the force of 5 Newton and 5 Newton. Okay. So how much force am I applying? Actually 10 Newton, right? So distanced by say 1 meter. So what is the real moment of force that I will get? It will be 5 into half meter plus 5 into half meter. Yes or no?
Yes.
So 5 into half meter plus 5 into half meter. This is very interesting. So automatically what will happen? It will become 5 Newton meter. It will become 5 Newton meter. Yes or no?
Yes,
Right?
sir.
Okay. Suppose if instead of putting the pivot over here, I put the pivot over here and do not apply this force. Simply apply 5 Newton force over here. What will happen? Again, I will get the moment of 5 Newton meter.
Yes.
Yes, no? Getting my point, what am I trying to say? I'm saying if suppose I fix the pivot over here, the distance is 1 meter, I straight away apply the force of 5 Newton over here, what would be the couple that will result into? It will be 5 into 1 meter, so it will be 5 Newton meter, right?
Yes.
A single force of 5 Newton distanced at 1 meter pivoted at this point is creating the moment of 5 Newton meter, and here two forces combined are creating the effect of 5 Newton meter. So tell me which is better.
One force creating a movement of 5 Newton meter.
Think twice and then answer. I'm giving you time, you can think. I'm again repeating. In this arrangement, if suppose I apply the force of 5 Newton and 5 Newton, okay, and the distance is just 1 meter. So the total moment that is being created, moment of force that is being created is 5 Newton meter. If suppose I put the pivot over here and then apply the force of 5 Newton. Again, the distance is 1 meter. Force applied is 5 Newton. So automatically, again, the moment that is created is 5 Newton meter. Right? The moment that is being created is. So these two arrangements are there. My question is, which is better? To apply the couple of 5, 5 by putting pivot at center, or to apply just 5 Newton force by putting pivot on this side? Which is better?
To apply only one force of 5 Newton.
To apply only one force? Are you sure?
Yeah.
Everybody? Everybody, please take your time and tell me what exactly is going to be the scene. So it means this couple से अच्छा हम normal force लगा दें, because same force is creating the moment greater than that of the normal couple, right or not?
Yes.
Right? But
Yes.
which is
Sir.
useful. See, understand. There is no comparison between both of them. First point you need to understand. There are differences of usage. None of them is better than each other. It is just the case like this. When you talk about couple, understand this. When you talk about couple, what really happens is, if I'm applying the force here, see, look at this. The moment of force is generated. If I go at this point, again the moment of force is generated. If I go at this point and try to move it, again the moment of force is generated. The beauty of couple is that it is independent of any pivot point. You don't have to fix the pivot point. In case of moment of force, if you are applying the normal force as such, अगर आपने normal force सिर्फ लगाया by fixing a pivot here, then the fixation of pivot becomes important, right or not? Yes, no? Right? So the fixation of pivot there becomes important, right? While in case of couple, fixation of pivot doesn't matter. So it is independent of pivot point. What? Couple by itself decides कि उसका pivot क्या होगा. समझा? तो सबसे पहला कपल यूज करने का फायदा यह है कि आपका सरदर्द खत्म हो जाता है कि आपको पिवोट पॉइंट फिक्स करना भी है कि नहीं करना है. कभी आपने नल खोला है? नल खोला है? नल. अच्छा, जब आप नल खोलते हो तो आप दोनों साइड से फोर्स लगाते हो कि नहीं लगाते हो?
हाँ.
आपका नल खुलता है. अच्छा, दोनों साइड से आप जितना फोर्स लगाते हो, अगर आप एक साइड से फोर्स लगाओगे तो भी तो नल खुलता ही है.
हाँ.
अगर आपने एक साइड से फोर्स लगाया सर तो भी नल खुलेगा. जैसे एग्जांपल अभी समझ लो ये नल है ना, मैंने सर ऐसा खोला तो भी खुलेगा, और मान लो मैंने सिर्फ ऐसा धक्का दिया इसको तो भी खुलेगा, कोई दिक्कत नहीं, खुलेगा तो है ही. राइट? तो क्या होता है, जब आपने यहां से फोर्स दिया तो क्या इस पे खाली मोमेंट लगा? नहीं, इस पे ऑटोमेटिकली करस्पॉन्डिंग कपल जनरेट हो गया बिकॉज ऑफ नॉर्मल रिएक्शन. नाउ अंडरस्टैंड दिस. तो ये जो कपल जनरेट हो रहा है, कपल इज द नेचुरल फिनोमिनन. कपल इज द नेचुरल फिनोमिनन. अगर आपने एक पर्टिकुलर पॉइंट को कहीं भी रखा तो कपल ऑटोमेटिकली जनरेट होता है. सेकंड पेयर ऑफ फोर्स इज ऑटोमेटिकली जनरेटेड बाय द सिस्टम. कपल इज अ नेचुरल फिनोमिनन. इस बात को आप लोग दिमाग में बिठाइए, पहली बात. दूसरी बात, इफ यू अप्लाई द एक्सटर्नल कपल, दैट एक्सटर्नल कपल इज इंडिपेंडेंट ऑफ द पॉइंट ऑफ पिवोट. दिस इज वेरी इंपॉर्टेंट. दिस इज वेरी वेरी इंपॉर्टेंट. और यही रीजन है कि कपल इस दुनिया में एग्जिस्ट करते हैं, जबकि डायरेक्ट मोमेंट ऑफ फोर्स जो हम लोगों ने निकाला उसका वैल्यू ज्यादा होता है, उसका इंपैक्ट भी ज्यादा होता है. लेकिन क्योंकि वो वाला हमेशा पिवोट पॉइंट डिपेंडेंट है, इसीलिए हम लोग इसको बहुत यूज करते हैं, बिकॉज दिस इज इंडिपेंडेंट ऑफ पिवोट पॉइंट. गॉट माय आंसर? आप लोगों को बात समझ में आ रही कि नहीं आ रही?
Yes, sir.
So even though moment of force वैसा हो रहा था, but it was dependent and this becomes independent. The beauty is this, and that is the reason why couple is being used so profoundly these days. आपने कभी मशीन चलाते हुए देखा है? कोई भी गियर बॉक्स चलते हुए देखा है? कोई भी व्हील मोशन चलते हुए देखा है? सब में कपल लगता है, सब में कपल है. आपने नोटिस किया जो बीयरिंग्स घूमती है, ऐसे बीयरिंग्स होती है, वो घूमती है, उसमें पट्टा लगा होता है ना? यस नो?
हाँ.
तो एक पट्टा यहाँ पे धक्का देता है और दूसरा पट्टा यहाँ पे धक्का देता है कि नहीं देता है ना? सो देयर इज कपल. सो कंसेप्ट ऑफ पुली कंप्लीटली वर्क्स ऑन कपल. Clear? So couple becomes very special because of this existence. राइट पक्का. और एक बात बता दूं, जैसे कपल की हम बात करें, कपल दुनिया और कुछ नहीं है, कपल भी फोर्स है. इट इज जस्ट द पेयर ऑफ फोर्स. वन फोर्स इज व्हाट यू अप्लाई, सेकंड यू मे अप्लाई और इट विल अपीयर बाय इटसेल्फ. इट डिपेंड्स ऑन द सिस्टम. जैसे आपने यहाँ पे इस पट्टे को खींचा, तो इस पट्टे को आपने खींचा तो ये यहाँ पर जाएगा, तो यहाँ पे आपने फोर्स लगाया, ये वाला फोर्स ऑटोमेटिकली जनरेट हो जाएगा. गॉट इट? सो इट डिपेंड्स अपॉन द सिस्टम. कपल जो है वो जनरेट हो जा रहा है या आप एक्सटर्नली जानबूझ के लगा रहे हो, दैट डिपेंड्स. लेकिन पॉइंट इज कपल इज यूजफुल बिकॉज इट बिकम्स इंडिपेंडेंट ऑफ द सेंटर ऑफ, it decides its center of rotation by itself. This is the beauty. Yes, and that is why the object starts rotating at the geometric center. यहाँ पे इसका एक्सेल होता है और उस एक्सेल के अगेंस्ट ही घूमेगा. आप कुछ भी कर लीजिए, नहीं घूमेगा. गेटिंग माय पॉइंट? यस. और आप कपल के बदले इसको खाली सिंगल फोर्स से खींचिए. आप कपल के बारे में मत काम करिए, इसको सिंगल फोर्स से खींचिए तो ये रोटेट होना चालू हो जाएगा. नोटिस किया है? या इसमें कुछ हो सकता है ये स्लाइड भी हो जाए, लेकिन अगर आपने कपल लगाया तो ये पक्का रोटेट होगा, गारंटी है. Getting it? Yes. So this is the importance of couple. So today's work was to understand this difference. Now your homework is to understand the importance of couple. Think about the scientists who have initiated their researches into couple and get through those points pretty easily, right? So couple तुम्हारे दिमाग में इस लेक्चर से तुमको लेकर जाना है. एक तो इक्विलिब्रियम जो हम लोग ने ऑलरेडी सेट में बना के रखा हुआ है. दूसरा जो आप लोगों को लेकर जाना है वो है couple, right? So you have to take home the couple with yourself. Okay, so you will discuss, you will understand, you will analyze the concept of couple, how important the couple is, how useful the couple is, and how can you really deal with all those things. This is what is needed, right? So your homework is now to do some research as being the part of an ICSE curriculum. It is important that you do some research with respect to couple, moment of force, equilibrium, and then solve the numericals from that center of gravity wala part as well. Center of gravity we had already discussed. Correct? So part A and B has been discussed. Your responsibility is to cover all the numericals from those two sectors. Learn something about couple. Tomorrow when we will be meeting, we'll be discussing about uniform circular motion. Okay, and I will try to complete the chapter by tomorrow. All the questions which are there in the exercise part, including theory questions and numerical thing and everything, you guys need to solve all of them into a notebook. Make a separate notebook, solve them very very practically. Okay, solve it with a complete seriousness as if you are solving the paper itself, right? That day Shraddha madam had already told you that will help you to make your own personal notes. This is something very interesting. I really liked it. You people must do it as if you are making the notes. Do the research, put some new ideas, put some new concept. If you find something really interesting, you can ask in the lecture and make the notes somewhere in the corner, maybe in the top of the setup. Use some different color of pens. Use some, decorate the notes with the will of yours. Do not over decorate, but simply make it appealing, a sort of interestingly involving, and those things have to be done from your side. I expect that you will do it. Okay? Yes. So
Yes, sir.
so maybe I'll be now completing the lecture from here for your sort, and it is by the way getting to be over soon, right? So I think yeah, it's done. Okay, so good night, take care, and just do it well. Bye.
Bye, sir.
I'm just ending the meeting now. It's already done by the way.